Welcome to my second tutoring session in A-level chemistry. In this video, I'll give a detailed explanation about element and its importance with suitable examples. Here's an overview of my second tutoring session. I'll begin my session with introduction to element, with its importance and discussion with suitable examples. This will be followed by a brief talk about periodic table of elements. Later, I'll explain the atomic structure of the elements hydrogen, carbon, nitrogen, and oxygen. Next, I'll explain the properties of elements. And finally, I'll end my session with key takeaway points and summary. Elements are fundamental substances that make up all matter in the universe, including both living and non-living matter. Living thing or matter is anything that has life, including humans. Elements carbon, hydrogen, oxygen, and nitrogen make up 96% of human body, and human DNA is made up of elements carbon, hydrogen, oxygen, nitrogen, and phosphorus. Non-living thing or matter is anything that has no life. Elements carbon, hydrogen, and oxygen make up a cardboard box. Certain elements exist in the form of individual atoms, like in the case of silver and gold, while other elements exist in the form of molecules, like hydrogen, oxygen, chlorine, and nitrogen. The noble gas of group 0 are monatomic in nature, and these noble gases are helium, neon, argon, krypton, xenon, radon, and oganosine. An element is a fundamental substance that cannot be broken down into simpler substances by chemical means. As you all know, molecules are made up of atoms, and these atoms are interconnected by bonds. And if you want to break down a molecule, you have to break these bonds that are interconnecting the atoms, and this is possible only through chemical reactions. Process like the electrolysis of water will explain this. Water undergoes electrolysis, liberating hydrogen and oxygen gas. In the water molecule, oxygen atom is covalently bonded to two hydrogen atoms, and during electrolysis, the two covalent bonds are cleaved, and this results in generation of hydrogen as well as oxygen gas. Compounds can be broken down into elements by chemical reactions. In case of breaking down of water, the process involved is electrolysis, and this process makes use of electricity or electrical energy. Now the elements hydrogen and oxygen, it cannot be further broken down because element is a fundamental substance that cannot be broken down into simpler substance by chemical means. Let us recall the structure of atom. Now atoms consists of a nucleus containing protons and neutrons surrounded by electrons in orbitals. They do not undergo chemical reactions that break down their structure into smaller particles without losing their chemical identity. Let us consider an example of sodium atom and understand why it is difficult to break down an atom. To break down an atom, one must either remove or add a proton to the nucleus, and this process, known as fission or fusion, it requires an immense amount of energy. Now you may ask me why it requires an immense amount of energy to remove a proton from the nucleus. Now the nucleus of any given atom, as you all know, contains positively charged protons and electrically neutral neutrons. Now the protons and neutrons are held together in the nucleus of an atom by the strong nuclear force. It's also called as strong interaction or strong force. Now this strong nuclear force is responsible for binding the protons and neutrons within the nucleus, and this plays a vital role in the stability of matter. Now this strong force, it is effective only within the nucleus, that is within a short distance or short range. Protons are positively charged and electrons are negatively charged. Now the positive and negative charges would naturally attract each other due to electrostatic force. This attraction between the positively charged protons present in the nucleus and the negatively charged electrons in the shells around the nucleus is what holds the atom together. While the balance of positive and negative charges ensures that the atom is electrically neutral. So therefore, to remove a proton from the nucleus, you need to overcome two major forces. One is the strong nuclear force that holds the protons and neutrons in the nucleus of an atom, and the electrostatic force of attraction between the positively charged protons in the nucleus and the negatively charged electrons in the shells of the respective atom. So now you know why it is difficult to break down an atom. Let us consider the electron structure of elements sodium, magnesium, and aluminium. The identity of an element is determined by the number of protons present in the nucleus. So sodium element has 11 protons in the nucleus, magnesium has 12 protons in the nucleus, and aluminium has 13 protons in the nucleus. So if I say element has 12 protons in its nucleus, so definitely it is going to be magnesium element. So the identity of the element is determined by the number of protons present in the nucleus. To break down an atom, one must either remove or add a proton to the nucleus. And this process, as I already mentioned, it requires an immense amount of energy. And this process is called nuclear fission or fusion. The number of proton defines the element, and altering this number would lead to a change in the fundamental nature of the atom, that is, it transforms. So whenever there will be a change in the protons, number of protons, it leads to transforming one element to a different element. Now nuclear reactions including fission and fusion can be utilized to accomplish this goal, and nuclear reactions definitely can change an atom's atomic number. Let us see what happens when we try to alter the number of protons and electrons in the elements sodium, magnesium, and aluminium, and later find out what happens when you try to alter the protons and electrons in these elements, and whether the element loses or retains its identity. Sodium has one valence electron, magnesium has two valence electrons, while aluminium has three valence electrons. Let us recall the definition of ionization. What do you mean by ionization? So ionization is a process where an atom tends to either gain or lose electrons and in the process gets ionized. When magnesium undergoes ionization, initially it loses one of its two valence electrons, and after the first ionization is complete, there is a change in the oxidation state from 0 to +1. When the magnesium ion in the +1 oxidation state, when it further undergoes ionization, it loses its second valence electron, whereby its oxidation state again changes from +1 to +2. Now finally we see that even though the magnesium has lost two of its valence electrons, it is still retaining its identity. It still remains as magnesium. Though it is in the ionic form, it still retains its identity as magnesium even after losing two valence electrons. So what is the change that you observe? So the only change is that the oxidation state of magnesium has changed from 0 to +2 while retaining its identity. Now this is what happens when you try and alter an electron in a particular atom. Now let us see what happens when you try to alter the protons. When magnesium loses one proton, it loses its identity, and that will be sodium. When magnesium gains one proton, it again loses its identity, and it will be aluminium. So it's just a hypothetical example that I considered to make you understand what happens when an element either loses or gains a proton. Now here the takeaway for this particular discussion will be that an element retains its identity when it loses or gains electrons, while element loses its identity when it gains or loses proton, which is definitely a highly energy demanding process. Now elements are the building blocks of matter and are composed of identical atoms, each with a specific number of protons in its nucleus. In case of sodium element, we find only identical sodium atoms within the element, and each sodium atom has a specific number of proton in its nucleus, that is 11. An element is a pure substance made up of only one type of atom. Here in case of sodium element, it is made up of only sodium atoms, and each sodium atom has a specific number of protons, that is 11. Similarly, magnesium has 12 protons in its nucleus, aluminum has 13 protons, silicon has 14 protons in its nucleus, phosphorus has 15 protons, sulfur has 16 protons, chlorine has 17 protons, and argon has 18 protons in its nucleus. Now, protons are positively charged subatomic particles located in the nucleus of an atom, and they are of paramount importance because they define the identity of an element. If I say a given element has 16 protons in its nucleus, then it will be element sulfur. And if I say element contains 13 protons, it will be aluminium. And if I say element contains 11 protons in its nucleus, it will be sodium. So each element has a specific number of protons in its nucleus, and that definitely leads to the identity of an element. So protons play a crucial role in the identity of an element. The elements are organized in the periodic table based on their atomic number, which is the number of protons in the atom of that particular element. Now here is a simplified and concise version of periodic table, and one can find the element of interest in the periodic table based on either its atomic number, its symbol, its name, or even by its atomic weight. But the simplest way of finding an element in the periodic table will be by its symbol or by its name, rather than finding an atomic, finding the element in the periodic table by its atomic number or atomic weight. I can see that I have highlighted only 4 elements in the periodic table. Now the reason being, these are the 4 elements that are common to all living organisms, including humans. Now these elements are hydrogen, carbon, nitrogen, and oxygen. So these 4 elements, carbon, hydrogen, oxygen, and nitrogen, they are common to all living organisms, and they make up nearly 96% of human body. And the human DNA is made up of 5 elements: carbon, hydrogen, oxygen, nitrogen, and phosphorus. Hydrogen is the first element in the periodic table because its atomic number is 1. And why its atomic number is 1? Because hydrogen has only 1 proton in its nucleus. Carbon is the 6th element in the periodic table because its atomic number is 6. And why its atomic number is 6? Because carbon has 6 protons in its nucleus. Nitrogen is the 7th element in the periodic table because its atomic number is 7. And why its atomic number is 7? Because it has 7 protons in its nucleus. And finally, coming to oxygen atom. So oxygen element is the 8th element in the periodic table because its atomic number is 8. And why its atomic number is 8? Because it has 8 protons in its nucleus. So elements are organized in the periodic table based on their atomic number, which is the number of protons in the nucleus of that particular atom. What are physical and chemical properties of the elements? Physical and chemical properties of elements are characteristics that help us describe and understand the behavior of elements and compounds. The physical and chemical properties of elements describe their characteristics and behaviors, shedding light on how they interact with their environment and other substances. What is a physical property? Physical properties are attributes of a substance that can be observed or measured without changing the substance chemical composition, and they relate to the substance physical state and characteristics. Let us consider sodium element as an example. At room temperature and pressure, sodium element is a solid and it's a soft silvery white metal. Its density is approximately 0.97 grams per cubic centimeter. Sodium is less dense than water, so they tend to float on water. And do not try this in the lab because sodium reacts violently with water and it liberates flammable hydrogen gas. And not only that, when you treat sodium metal with water, It liberates X amount of heat, and definitely it is a exothermic reaction. It will lead to a explosion. So do not try this in the lab because sodium reacts violently with water. What is a chemical property? A chemical properties describe how a substance interacts with other substances. It undergoes chemical reactions and changes its chemical composition. A simplest reaction that can be mentioned for sodium metal is that it reacts with oxygen to form sodium oxide, and that is why you can see silvery white sodium metal changes to grayish black upon exposure to air due to formation of sodium oxide coating or layer on the surface. So this grayish black layer or coating, what you see, is because of formation of sodium oxide when sodium metal is exposed to air. And therefore, utmost precaution has to be taken when you're storing sodium metal, and it must be stored in a closed container under mineral oil, toluene or kerosene. Now here are the key takeaway points for my second tutoring session. Elements are fundamental substances that make up all matter in the universe, including both living and non-living matter. An element is a fundamental substance that cannot be broken down into simpler substances by chemical means. Elements are the building blocks of matter and are composed of identical atoms, each with a specific number of protons in its nucleus. Elements are organized in the periodic table based on their atomic number, which is the number of protons in an atom of that element. And one can identify or find an element in the periodic table based on its atomic number. Like for example, you can find the element sodium in the periodic table based on its atomic number, that is 11. Physical and chemical properties are characteristics that help us describe and understand the behavior of elements and compounds. And finally, in summary, elements are fundamental substances that make up all matter in the universe. They're composed of atoms with a specific number of protons, and each element has its own set of properties and uses. The periodic table is a valuable tool for organizing and understanding the properties of elements. Elements are distinct types of matter that possess unique chemical and physical characteristics. There are 118 elements in the periodic table, but only 92 of them occur naturally. The rest of the elements are artificially synthesized in laboratories and are unstable. And it's interesting to note that only 4 elements are common to all living organisms, including humans. That is oxygen, carbon, hydrogen, and nitrogen. And together, these 4 elements make up approximately 96% of the human body. Thank you so much for watching my video. Hope you enjoyed it. And I'll meet you in my next interesting tutoring session.